Goal in this exercise. Welcome back to the vector arithmetic, visual numbers. Otherwise, our goal is to move us to the knowing of these fractal, vector computation or vector numbers, fractal numbers that are vector computation. Our goal in this series, in this segment, is to construct a regular polygon that is divided into 3 parts. So our goal is to construct a regular polygon that is divided into 3 parts. From a blank page, of course, we know that we need our instrument compass that we use to generate circles, the straight edge that we use for drawing lines, and a plane. On a blank page, we inscribe 2 points like this, point, and we can label these for vocabulary purposes A, B. We said when we have 2 points, we can draw a line segment, like I'm doing now, from A to B. And I'll take the privilege this time again, like we say, we can extend them on either side. It's a distraction there. We take our compass, adjust to this line segment, AB. We center our compass at the point A, going through point B. We construct a circle. From point B, going through point A, we construct another circle. We have a crossing above and below. Center our compass at this crossing above. Push. We center a circle. And at the crossing below, center a circle. Again, we started off with a blank sheet of paper and 2 points A, B. We drew a line segment from point A to point B, and we extended it on both sides. When we did that, we noticed new crossings. AB has been self-replicated from B to this point and from A to this point. For vocabulary purposes, this crossing above here we call C, and this we call C prime. You will know why we call this C prime. We did all of this in black. We draw a line segment, need us to draw a line segment from point C to C prime, and we extend it till it touches the top here, and so it will go like this. We call this B prime, and we'll call this point A prime. We draw a line segment from point B to B prime in green. We draw a line segment from point A to A prime in green. And of course, we re-emphasize this line segment again from point C prime to C, and we extend them. You notice that the green line segment from point A to A prime, the green line segment from point B to B prime, and the green line segment from point C to C prime, the three of lines meet over here. At that point, that will be the center going through this point, and this point of a regular polygon that is divided into three parts. So we adjust our compass. This is from the open source knowledge. No patent. This is arithmetic. You cannot patent it. The utility, yes, could be patented. So center our compass here in green, going through point C, A, and B. We constructed our circle. These green circles centered here, so we can as well make it centered at this point. We can call this C3. It's a regular polygon that is divided into three parts. Let's draw the line segment to see that. B to point A, C, and C to point A. When we look at this now, we can say, the triangle ABC is inscribed in the green circle. Again, in the green circle, we inscribe equilateral triangle ABC. So, if we want to know the radius. So what is the radius? What is the radius of this circle? Centered over here, and we already know that this distance is from here to here is 1/3 the square root of 3. We've already generated earlier on from our previous drawing that this distance is square root of 3. This green circle, which will be centered at point A, is the square root of 3. We've already said that earlier on. So if this is square root of 3, this distance C prime is equals to square root of 3. We generated that from our previous drawing, and that's why we started with that, the generation of square root numbers. So this distance from A to this point here, we can draw another crossing, and from B to this point here. By the time we do this, we find out that this distance C prime has been divided into three parts. These crossings, and this crossing. So from here to here is 1/3 square root of 3. From here to here, this point C to C3 is 1/3 square root of 3. So we can say the regular polygon that is divided into 3, the trigon, is equal to the radius is equals to radius of is equals to 1/3 square root of 3 for the trigon. For the trigon, for vocabulary purposes, we're going to call this trigon. Thank you for this segment. We're going to continue again